Hello, we are Group 5. This is our midterm assignment. We have with us Christine Hill, Catherine Flores, Ken Hodgson, and Eric Blackham. Today we are talking about the 7 steps to functional development. These are the 7 steps.
So the first step is to clearly define the problem. You need to determine what the function needs to do, the inputs, what output is returned, and what validation rules need to be enforced. So in our example with the calc volume barrel function, it takes in some input parameters, it outputs the volume, and it checks to make sure that the input parameters followed by these rules. So height can't be height has to be greater than 0 and no larger than 60, and the radius has to be greater than 0 and no larger than 18. After you define the problem, you'll create a test matrix, and you'll get some examples of some valid inputs, invalid inputs, and the boundaries that you set up with your parameters. And in our example, we have valid input 12 and 36, and it runs through all of these examples, these test cases, and shows what the output should be if our function is working correctly.
All right, the next part is to outline the solution. So basically you're going to want to write an algorithm in pseudocode, meaning that it doesn't have to be in the correct syntax. You just want to get your logic out there. So in this example, like Catherine said, we want to make sure that our height is greater than 0 and less than or equal to 60. We want to make sure that our radius is less than 0 and less than or equal to 18. Then we have our function that will actually calculate the volume of a barrel using the parameters that we set, radius and height, and then you return the volume, and that's our pseudocode. And then you'll want to actually test the algorithm that you did. So you'll want to pretend like you are a computer and just go through each of the examples. So for the first one, the first input radius is 12, the height is 36, that's valid. It comes back to 9.42, and then we just go through the rest of the test cases.
Okay, so defining the function signature. On the upper right corner we have a public function, so it's available everywhere. The type that it will return is going to be a double, and the name is calc barrel volume. It will ask for 2 things, height and radius, both of which are types double. And you can see down in the lower left we have that pseudocode that Eric described earlier. Translating that over onto the right, we see that that is now written into code understandable by Java, or in Java. And we can see that the beginning and ending of a block is highlighted in yellow with curly braces.
After translating the code into Java, then we create a test class where we can test each of the functions parameters. So first you create the unit test as it's defined in the test matrix, and then you check for success. If it fails, you'll get this report as shown in the image. Lots of bright red, and if that happens, then you run the debugger, try to find the problem, fix the code, and then run the test again. When the test is successful, it will be green and say it passed. It's important that we don't push our code until everything passes 100%, so we don't break the code. Okay, for the individual section, we'll talk about selection statements. We have if, else, and switch statements. This first one is an if statement. An if statement can either be true or false with a single condition, and it is executed only if it's true. An if-else statement, the second one, also has a single condition, but it has 2 different executions. If the first one is false, then it'll execute the second. A switch statement tests multiple cases. Each condition has its own execution, and if none of those is true, then it will go to the default, and in our case we have it displaying an invalid selection message.
Catherine, you need to unmute your microphone.
Thanks.
Different cases. I'm going to show you my test for trade control test function. This tests each of the inputs in the test matrix in 10 different cases because this one has 4 parameters. So the first one tests valid inputs. The second one tests for a too low input on number 1. The second one tests for too low input on number 2. Number 4, this one tests for too high of an input on the 3rd parameter. This one tests for too high on the 4th parameter. Number 6 tests for too low on parameters 1 and 2, which is required because of having 4 inputs at too low to have it come back invalid. So number 7 tests the upper boundary of 100, which is over 99. This one tests the upper boundary for number 1 and number 4. This one tests the lower boundary on the 3 and 4, the negative inputs. And number 10 tests the valid inputs. So I will run the test. And you can see that it comes back all 10 passed.
So Christine went over the 3 different types of selection statements, and I'm going to go into detail on the switch and the if selection statements. So this particular example is from the checkpoint view, and it asks for a user input of a letter. They choose a menu option, and depending on which letter they input, it's going to run a function that's associated with that letter. And each case has a break statement in it, and that prevents the other cases from being run. And so it'll go through each case until it finds one that matches the user input, and then it will run the function and break. Then on the right side is an if statement, and this is from the health control class, and this has the parameters that check the health level. We can't have a health level less than or equal to 0. 0 is dead. And the health level maxes out at 100, so they can't exceed that health level of 100. And if none of those are an issue, then it checks the next if statement. If health level is less than 5, then it's going to return 0. And then for the control function that I tested, it has 3 functions. It has a calc help decrease, calc help increase, and those are pretty self-explanatory. They increase or decrease your health depending on some event happening in the game. And then the last one, this calc status, it gets your status based off of the health level.
So this is the health control test, and for each of those 3 functions, it has our test cases, and those came from the matrix for each of those functions. And so for each of the functions, right, we have the test calc decrease. For each of those functions, there is a group of test cases, and it runs through each of those test cases to check to make sure that the functions are returning negative. Each of those make up each function. Just have health increase. And here is the test status. So we can run that. Help decrease test case 1 to 5 passed.
Okay, so I have basically the same thing as Catherine. I And Christine also had an example of if else, and the switch statement. This first one is for a decrease inventory item function. The if just checks the boundaries, making sure that in this case that it's equal to, or that it's not less than or equal to 0, and that it's not greater than 30. Else statement displays the first option. If this happens, then we want to display the barrel volume calc view because it's correct, or else we'll do a different scenario. And then the switch statement, as previously mentioned, just has different options that depending on what the case is, then that is what will happen in result. And so for my example, I'll go over the inventory control statement and how we've created a test case for that.
I'm real quickly going to go over inventory control. This is a function that we created to either add or decrease the item quantity of be less than 0. If you're adding to it, it cannot be greater than or equal to 30 if you're adding to it. It cannot be equal to 0 or less than 0. And it must be greater than, or if it's, and it cannot be greater than 30, excuse me. So let's go over and test this real quick. So we're here in the inventory control case. I have a different case that just showcases the upper boundaries, lower boundaries, and what it should, if it should run correctly. So in this first test case 1 here, the item quantity is 5. That's a valid result. It should just add 1, add 6. And then in this test case number 2, we are making sure that if the item quantity is too high already, that it comes back with a negative result. In this test case 3, it's below 16. We want to make sure that the result is a -1, which indicates an error. If it's and then we test the upper boundary, making sure that if it's 29, that's the highest that you can have. Make sure that it comes back as 30. And we're testing the lower boundary as well. We do the same thing for the decrease inventory. I'll just go ahead and test it real quick. And let's go ahead and look, and yep, it came back 100%, so everything works great.
Okay, here we have 2 different types of selection statements. On the upper left, we have a switch, which again is just going to go through the 3 different potential cases. Either they enter the first letter, the second letter, or a default response, which is anything else, will return that 3rd value. On the bottom right, we have an if. There are 2 ifs. If the subtotal is less than 0, and then the second one, if the tax is less than 0 or the tax is over 100, it also returns a -1. And the 3rd option, of course, is the default, and it just begins to calculate the rest of the function. I have here our test calc wagon cargo weight, and this is the result here of all of our test cases in the matrix that we created. 1, 2, 3, 4, all the way up to 7 different combinations of theta. When we run this test, we control F6. Goes through every scenario and should pull up successful results in all 7 cases, which it does.
So the scope defines the section of a code that a variable is visible. So in this example, we have a variable menu, and the variable was declared outside of any function, and so its scope is broader. If it had been declared within a function, then that variable would only be available within the function. So this variable menu was declared at the top of the class, and so we can use it in this get menu option function. and it allows us to take the whole block of text with the menu options and not have to type it out every single time we need to use the menu.
Going right along with scope is lifespan. The lifespan of a variable dictates when a variable is active in memory and can be used. Memory is then allocated for a variable each time a new instance is created. A variable's life ends when execution reaches the end of the block that it's defined in. The memory allocated for the variable is then freed. Essentially, when you leave the scope of the variable, its life is ended. In this example, we've got the variable that's being passed in as item quantity. In this instance, its life is started when it's first declared. Its life then ends at the end of this code block, which is indicated by a highlighted curly brace.
Only primitive values are passed by value. Actual values are passed to the corresponding parameter in the function when it is called. So you can tell that it's a primitive value and being passed by value when you can actually look in your code and see the number and tell exactly what it is, as you can see below in the diagram.
Object instances are passed by reference. The location of the object in memory is passed and copied. It allows original objects to be updated in memory. The first image shows a function that is created in the trading control class with 4 parameters. In the second image, a new object instance is created in the by supplies view. The new keyword creates a new instance, an object instance of the trading control class. In the third instance or image, user inputs are passed to the function, and then purchases can be saved in memory and updated with later purchases. And that is our presentation. Goodbye.